guys. So today what we're going to do is we're going to do lesson 7 in unit 9, and this is basically like a summary of all of the ways that you've learned how to solve quadratic equations so far. So now that we have a large variety of ways to solve quadratic equations, which is of course polynomial equations whose highest power term is x squared, we're going to be able to kind of get a feel for when one method is easier or when one method is a little bit better to use in general. The techniques that we've learned so far are factoring, completing the square, and using the quadratic formula. So in each application, it is essential that the equation that we're solving is equal to 0. If it isn't, then some minor manipulation might be needed. So that's what we're going to be practicing today. So for exercise 1, oh my gosh, what is that on my nail? On exercise 1, we're going to solve each of these equations using the method that's stated. The first thing you need to do, though, is to rearrange it so that it's equal to 0. Remember, we can't use any of these methods until it's set equal to 0, okay? Because the whole point is finding those zeros. So for part A, we're going to use factoring. So if we take a look here, we can see clearly it's not set equal to 0 yet. So we're going to slightly manipulate our equation by bringing everything over to the left. So I'm going to take this 8x and I'm going to subtract it so that it's on this side. Of course, guys, remember we're lining up with our like terms. And in the same step, I'm going to add the 2, just so I can save myself a little bit of room. So now this is x squared, and this is 5x minus 8x, which is negative 3x, and then negative 12 plus 2, which is negative 10, is now equal to 0. So now I have my quadratic equation set equal to 0. So now I'm going to use the factoring. So you can see that there's a 1 for my a value, which means I can use double bubble. So I'm going to double bubble it. It's x and x. And now I look at my last term. It's negative, which means that the two signs are different. So one's plus, one's minus. And the middle term being negative tells me that the larger number is going to be the negative number. So I'm thinking of factors of negative 10 that are going to add up to negative 3. And it's going to be 5 and 2. So I already know the 5 is going to be negative and the 2 will be positive. Okay? And now we solve. So we split it up. X plus 2 equals 0 and x minus 5 equals 0. And solving, x is equal to negative 2 and x is equal to 5. And remember, you can write those like this, or you can write them as a single set. If you're going to do the single set, make sure you put the smaller number first. Okay, voila. For part B, we are told to use the completing the square method. So again, we need to get those numbers on the right over to the left so that we can have our equation set equal to 0. So let's just quickly do a little manipulating. And again, I'm going to do it in the same step, okay, just to try to save some space here. So I add 3x to both sides, and I'm subtracting 4 from both sides. And I end up with x squared, and this is going to be negative 12x plus 20 equals 0. And now we're all set equal to 0. Now it's time to complete the square. So we go for the middle term, negative 12 divided by 2. That's negative 6 squared, which is 36. So I'm going to be adding and subtracting 36. So I get x squared minus 12x plus 36. Now minus 36 plus 20 equals 0. This is my perfect square trinomial, which I get from here, the minus 6. So this turns into x minus 6 squared. And then this is negative 36 plus 20, which gives me negative 16. So minus 16 equals 0. And now, if you recall, what we can do from here is we can solve using inverse operations. So I add my 16 to both sides. Now I have x minus 6 squared equals 16, And now I'm going to take the square root of both sides. And I'm left with x minus 6 is equal to plus or minus 4. So this is where we split up our answer, remember? So this is going to be x minus 6 equals 4, and x minus 6 equals negative 4. And now we solve. Adding 6 on both sides here, one of my zeros is x equals 10. And adding 6 on both sides here, one of my zeros, 6 minus 4 is 2. So my two zeros are x equals 2 and x equals 10. Or we could write that 2 comma 10. Okay? Next, for part C, we're going to use the quadratic formula, and we're going to express our answers to the nearest tenth. So in this case, we are not going to simplify our radical. We're going to put it in the calculator and see what we get. So, first things first, of course, this has to be set equal to 0, and it's not. So I'm going to move everything over. So I'm going to subtract the 5x, and I'm going to subtract this 15. That leaves me with x squared minus 8x plus 1 equals 0. So now we're going to use our quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, right? So let's identify our a, b, and c before we move on. A is equal to 1. B is equal to negative 8, not positive 8. C is equal to positive 1. Okay, so now let's plug everything in. Here we go. Negative, negative 8. That's a double negative, so I got to be careful. Plus or minus the square root of negative 8 squared minus 4 times a, which is 1, times c, which is 1. And that's all over 2a, so that's 2 times 1. Okay, so now this turns into a positive 8, plus or minus negative 8 squared is 64, minus 4 times 1, so that's minus 4. And that's all over 2 times 1, which is 2. Okay. So now this gives me x is equal to 8 plus or minus the square root of 60 over 2. Okay. So now what I'm going to do is I'm going to break this up, and I'm going to put it in the calculator. We don't have to simplify because they asked us to use the nearest tenth. So we have x equals 8 plus radical 60 over 2, and then we have 8 minus radical 60 over 2. Plugging into the calculator over here, we're going to get 0.127 da da da. So that's going to be in the nearest tenth, 0.1. And this one is going to give us 7.872 da da da, which is equal to 7.9 when we round it. So our two zeros here are 0.1, 7.9. However you'd like to write it. Just make sure you write x equals here. I'm a little bit running out of room. Okay, finally, we're going to do part D using the quadratic formula, but this time, when we get down to this part, we're going to write it in simplest radical form. So we're not going to use the calculator for that. So first, let's manipulate our equation so that we have 0 on the right. Okay, so quickly we're just going to add the 2x to both sides and subtract the 7, leaving us with x squared plus 6x minus 5 equals 0. Okay, so again we're going to use the quadratic formula. I'm going to write it out again. I'll write it up here just so I have a little more room. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, and when A is equal to 1 still here, B is positive 6, C is negative 5, so be careful with those negatives. Alright, so now let's plug everything in. So x is equal to negative b, so that's negative 6, plus or minus the square root of b squared, so 6 squared, minus 4 times a, which is 1, times c, which is negative 5, all over 2a, which is 2 times 1. Alright, let's see what happens here. We get x equals negative 6 plus or minus 6 squared is 36. Negative 4 times 1 times negative 5 gives me positive 20. So that's plus 20 all over 2 times 1, which is 2. Okay, so this is x equals negative 6 plus or minus 36 plus 20 is going to give me 56 over 2. Okay, so now what I need to do next is I need to try to simplify this 56. So this is going to give me negative 6 plus or minus. So you play around in your calculator to make sure you can figure out what the largest perfect square is. And in this case, the largest perfect square is actually going to be 4. It's going to be 4 times 14. So I'm going to change this into the square root of 4 times the square root of 14 all over 2. And this is going to become x equals negative 6 plus or minus the square root of 4 is 2. Square root of 14 over 2. And now I'm going to simplify this, right? Because I know I can divide 2 by 2 into all of these. So 2 goes into negative 6 negative 3 times. 2 goes into 2 1 time. So this is x equals negative 3 plus or minus the square root of 14. And that's your answer right there. And if you were to write that in the brackets, it would look like this. Oops, sorry. Okay, and that's that. Okay guys, so to finish up this lesson, we're going to have one final look at quadratic equations. And it comes as a tie between their zeros, which of course we know is where they cross the x-axis, and the algebraic solutions to find them. So what we have here is the quadratic equation f of x equals x minus h squared plus k. So they want us first to find h and k. So remember, this is our turning point. So what we have to do is look at the vertex of the function. So that's here. Then we can find our h and k. So this is 2, comma 1, 2, 3, 4. Right. So that means that the h is 2 and the k is 4. Right? So what happens if we try to solve for the zeros if we know h and k? And let's see what happens if we plug them in here. So we have x minus 2 squared plus k, which is 4. If we set it equal to 0, let's see what happens when we try to solve. Subtract 4 from both sides. And then I have x minus 2 squared equals negative 4. Taking the square root of both sides, oh, wait a minute. Can't take the square root of a negative, right? Not until algebra 2 and trig. Okay, so this is a no-no. We can't find any number that's going to multiply by itself and give us negative 4. Take a look at your graph. What do you notice? When we're solving a quadratic equation, what we're actually finding are the zeros. We're finding where the quadratic equation crosses the x-axis. And as you can see from this graph, it doesn't cross the x-axis. So it's not just a coincidence. It literally has no zeros. So you can't find them. Okay? So how does it find, oh, Kirky. So how does what you found in part B show in the graph? There are no zeros. The graph does not cross the x-axis. And so it makes sense, right? There's clearly no zeros. Okay, so if you think about the graphs of parabolas, they certainly can, quote unquote, miss the x-axis. So when this happens graphically, then when we solve for the zeros algebraically, you won't be able to find any real solutions. Although, as I just said, you will find what we call imaginary ones in Algebra 2. You guys have heard me talk about imaginary numbers before because I love them so very much. But you get to learn about those in Algebra 2 and Trig. So exercise 3, what you're going to do, and you're going to do this yourself and pause and try it, you're going to figure out which one of these, there could be more than one, I shouldn't have said which one, it might be more, which ones have real answers or real solutions and which ones do not have any real zeros. Okay, so for this one, for these three, please use the quadratic formula. And if you need to verify your answer, you can look in your calculators, and then you can see if it's actually crossing the x-axis or not. All right, so pause this, try all three. It might take a second, but try all three and see which ones give you real zeros and which ones are going to give you no zeros to be found, at least now. Okay, go ahead and try it. Okay guys, hopefully it didn't take too long, but you can see that the first one's going to have real zeros. As long as the number under the radical is positive, you'll have a real zero. So I went all the way through and I simplified, but didn't even have to do that. You could have stopped right here when you saw that 45 was positive. But the second example, what you see is you end up with a negative under the radical, which is not allowed in the real number world. So there is a negative there. It's not real. So you have no real zeros. And then finally this one, as you can see, you're going to have real zeros. It's radical 64 here, which we know we can find the square root of easily. Okay guys, so that's it. Today's really just using the 3 different methods that we learned to solve, and then also taking a look and seeing if there are real zeros or not. Okay, and that's it. Tomorrow we're going to do cube roots, and then that's the end of the unit. So we'll be reviewing, and we'll have our test on following Monday. All right, guys, have fun.